Hello guys, you're welcome again. We'll be running again how to obviously, perform data cleaning. As you know, we're dealing with dirty and messy data, so we obviously want to get our hands messy, or should I say dirty right now? Yeah, but that's how we build capacity in as a data analyst through cleaning various sets of data. So right now I'm just going to go to get my data. Ta-da! Here we go. All right, let me open my file. Okay. So, so I have lots of files here, but I'm just going to go with messy log data. We'll do some other ones later. So, this is it. So this is going to load up, and obviously it's going to load up into Power Query. And from there, we can perform our data cleanings. I mean, I love Power Query. I don't know, but it's just so interesting to me, right? I don't know why. If we could love any of those two, but I mean, all right. So here we go. So this guy has lots of rows. I'm gonna find out how many. So right now, obviously, like how we did before, we want to transform the data. We want to clean the data, right? So we just have to clean transform data. All right, so Power Query is opening. Can I say my love? I don't know, but yeah, Power Query is opening, right? Yeah, I actually love Excel, and after Excel, I mean SQL. After SQL is Power Query. All right, so yeah, so here we go. This is how we have it. Power Query just have a way of making things easy, right? I don't know, but is it just me? Someone else? Right, so this is what we have here. We have lots of rows of data here, and we have 15 columns and 999 plus rows of data. So actually that's plenty, right? That's much. But nevertheless, we are going to obviously have to perform this data cleaning and see how it goes today. And so we'll be doing all of this together and see where we go from there, right? So let's go. Let's go there. So we obviously have to spot some issues from this data. As you can see, has well name, in column 1. Under column 2, you have the name of the well, OML, composite well. Column 3, you have operator, which is Atlas Energy. Yeah, I mean, I kind of like the name Atlas, right? And then you have location, you have dates, which means the date has been logged, right? And all of these other things are null. So it's kind of inconsistent. We even have true here, triple combo, right? That's the last thing under the last column, right? It's kind of bad for re-representing our data. So the best thing for us to do here is obviously to remove these rows of data to make our data easy to read and easy to analyze after that. Of course, that's why we're cleaning data. So the first thing we do here, go down here and where's that? Not use first rows. Obviously, what we want to do is to replace, remove rows, remove top rows of data, right? So remove top rows. There are a lot of things to do, but first thing is to remove top rows. And how many rows of data we'll have to remove from well name to location to date lot? So that's three rows of data, right? All right. So this seems pretty cool now, right? This seems pretty cool right now. And okay, so we have that there. Looks cool, right? So but you can notice from this first column here, right? We have the depth of the well, 1500.95, 1500.95 meters, 1502.3.32, 1503.73 meters. So some of them are in meters, right? And some of them are just numeric, just numbers. So as you can see from here, right? You can see from this drill down. So obviously what we want to do right now is to replace m with nothing. We obviously just want to see numbers. So right click and replace values, right? We've used it before, right? So replace values. Of course, we know what replace values does. We want to find m and we want to replace that with nothing, right? So we are kind of booting out M. So this is it, okay? And this looks pretty cool right now. So trying to drill down, you are gonna see that We obviously don't have any M anymore, right? Okay, so all of these are numbers, okay? So this looks fine. This looks very, very good right now. So we're cool with this, right? The next thing to find out here is on this next column, gr underscore API, right? Um, okay, values are no data. Some of them are null values, which is cool, but some are no data, as you can see, right? No data. Trying to drill down here. Let's see what we got here. The last thing here is no data. So let's see how many of them are no data. Just for the fun of it, right? Okay. So let me go down and click this and press OK. Okay, so we have lots of rows, 133 rows of data under this column that doesn't have any value, just says no data, right? Okay, I'm just gonna go back and click everything, right, including the no data, right, and then kind of have to replace that. All right, here we go. So right now, right click and replace values. Replace values, no data. So replace no data with empty space, which means we want it to be null. It's easy to analyze data. It's easy for, to analyze after the cleaning use like that. Okay. All right, this is cool. Yeah, great. I get it. So this is it. Hope you're together, right? Okay. So and the next thing we have is resistivity measured in ohms meter, right? And we have a lot of plenty figures here, right? And we also have no data here, right? No data here, and some of these guys are large numbers, and I kind of want to see another large number apart from the other ones we saw. I saw something up. Oh, okay. Yeah, sorry. This is around 11 point something. That's quite good as resistivity value. So we kind of obviously have to separate this and put a flag to this, like according to best practice, like all the values, all the numbers that are greater than 50 should be put on a flag. Should be checked just in case there's an error with that, right? So obviously we kind of just have to add column, do that and see where we go. Add column, and this is going to be resistivity flag underscore flag, right? Yeah, just for that. And if resistivity, right? And then this is it. Resistivity greater than 50, then what? Then check, right? Else, what should happen? Should say everything is okay. All right, here we go. Okay, what we've got? Okay, there's an error there. It's a lot of errors there. Okay, there must be a problem. So, okay, this is important for us to go check back. All right, so going back to this resistivity, first of all, you can see that this resistivity obviously has no data, no data. So the first thing to do, right? First thing to do is to replace that. Right click, replace no data with null values, right? Okay, replace that. Okay, and the next thing to do is check this resistivity. The values in this column are in text format. I don't know if you can see my cursor, they're in text format. So obviously we have to do something and change this to decimal number to ease us, applying the knowledge or applying the conditional statement we want to apply. And obviously we'll do the same thing we did before. Resistivity. Okay, there we go. Underscore flag. And what we say here is if resistivity as before is greater than 50, but greater than 50, then what should happen? You should check this, right? That's the flag you're putting out there. Else, what should happen? Else, Uh, okay, everything is okay. Else, so it's got to check if resistivity is greater than 50. If it's not greater than, if it's greater than 50, then you should just write check beside it, right? Else everything is okay. So write okay. So this should be perfect, right? But I'm gonna drag this. It's gonna be right after the resistivity, all right, for easier analysis and understanding what I did. Okay, here we go. Okay, this is taking time right now. Just hang on. Here we go. Okay, here we go. Just gonna place it here. Right, so this is it. So this guy is greater than 50, greater than 50, um, greater than 50. Okay, greater than 50. And okay, seems okay, right? So the next thing to check here is this DT underscore Sonic, right? And what we have there is going to be, of course, we have to replace values. The next thing we are looking at is no data. So replace that with nothing, right? So that's what we'll have to clean on this line, in this column, I mean, sorry. And yeah, everything looks cool, right? Everything looks great. So the next thing here, this guy is TOC, supposed to be in percentage. All right, but I can see here from here, the values are unique and they don't have inconsistent values or additional values and all that. So, but what I'm going to do here is at this top, I'm going to have to put percentage right here. Yeah, very important. And this is caliper. Caliper is underscore in, which is inch. And so we can see this guy is at 8.0 something, 8 points, blah, blah, blah. We have 8 point, blah, blah, blah. Then there's an in there, which is inch, right? And if you go down, you have another in here, you have another in here. And so we really need to do something about this guy. We need to remove that. So of course, static cleaning is exciting. All you need to do is spot the errors and remove. So the next thing here is in, right? Replace with, okay, perfect, perfect. Let me just kind of do some drill down just in case there is something I'm missing, right? Um, kind of seems okay. All right, everything seems cool. All right, here we go. And the next guy is mod width. Mod width. The data in mod width, just gonna use this drill down to seems consistent. Right, everything seems consistent here. So okay. And this is ROP in meters per hour, I guess. So here, this column, okay, we have null values. Okay, yeah, but they're all original, so that's cool. Okay, here. So the next thing, the next column here is this bit size in. All right, since everything here is correct, it's in, right? So none of them had in on them. Let me kind of check that again. All right, so it seems cool. Seems cool. All right. All right, here. So the next thing is the temperature. Temperature is obviously looking the same, doesn't have some attachment to the numbers. It's cool. Okay. And this is pressure, PSI. So what we have here, pressure. Okay, everything seems cool as well. Kind of drill down again to see this in a better format. Okay. Okay. Yeah. So then porosity, how porous is the soil? Of course, these are well logged data, right? So try and check porosity, right? Okay, that's cool. Then here, what do we have here? This is lithology, right? And we have four, soil types or rock type. Yeah, rock types actually. And these guys are just okay as there. And well, ID, I guess OML 38 underscore A1. So all of these are having well IDs. Technically, this is supposed to be one where ID, right? Because I mean, this is well log data, and this is a data of a particular well. And I got this data from ChatGPT. Maybe sometimes I can show you guys how to get this data using ChatGPT, right? It's easier for you, just helps you to hone your data cleaning skills. Apart from there are other ways of getting data, right? But I got this from ChatGPT. All right, so I'm going to delete this row, this column. It's not needed. Right. So what we have here, I mean, which is the last column, is RHOB underscore MPHI again, right? So these guys are numbers 2.38 underscore 0.368, then 2.256 dash. So there are two things here. There are dash and underscore. Is there other things here I can see? Underscore. This is dash. This is underscore. This is underscore, 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 dash. This is dash, underscore, underscore. Okay, so the first thing to do is to replace the dash with underscores. Very important, right? So that's the first thing to do. Replace the dash with underscores. So anyways, it's dash. It replaces with underscore. We'll do that first. Very good. So we can make all the values unique. So now they are unique. So right now we can now separate the columns. We can now split the columns into two, because I think this is RHOB and one column, and then NPH has one column, which means the first number here is one number. The second number after the underscore is another number. So what we have to do is come down to home, right? Split column, and we are obviously splitting by the limiter. And like we said initially, the limiters are splitting by semicolons, by columns, by comma, equal sign, space, tab. But what we want to split this column with is using the underscore, right? So underscore and okay, right? Here we go. Yeah, we got it. Perfect. All right. So just kind of have to separate these, right? And gonna have to do the same thing here. And this gonna be hard. Gonna be like this, right? All right, here we go. Good, good, good. So here we go. Got it. So as you can see here, these guys are depths, and the next thing to do is to change these guys to decimal numbers because they are numbers. So and you can spot the difference. The decimal numbers or the numbers are actually aligned to the left of the columns, and those guys that are left as text are just aligned to the left of the columns, right? So, and here we go. This guy is perfect. This guy is already in decimals. And of course, this lithology is going to be left as this text. Yeah, it's text. And next thing here, we have to sort this guy. Okay, before the sorting, we have to right click. After the right click, we kind of have to remove duplicate rows. It's important, remove duplicates. Okay, we have removed duplicates, and what we have here now is to sort this guy in ascending order, right? Ascending order. Okay, we have one null, and then it started from 1500.25, 1500.993. So sorting that in ascending order obviously makes it easy for us to see our well from, the last till end. I mean, from when they started getting the data to obviously when, the last set of data in terms of the depth, right? So that's what we're trying to do there. So it's kind of very good to see that we have done a lot of cleaning, right? We've done a lot of cleaning here, and kind of seems cool, seems okay, right? And yeah, 16 rows of data over 919, the 16 columns of data and over 999 rows of data. That's a lot of data, right? So, and trying to scroll down to where we like kind of find, you know, the last row of the data, right? Okay. So this is all of the query that we have to go, right? And then this is it. I hope you learned one or two from here. See you in our next video.